Hi everyone. Today for this video we are going to look at how we can charge a conductor, and let's begin. Okay, so in the previous lesson you should have know that we can charge an insulator by friction. So simply by rubbing insulator with a cloth, we can rub away some electrons, or the insulator may gain electrons so that it becomes charged. Now conductors cannot be charged in this way because which we call it charging by friction, because the mobile electrons simply move and rearrange themselves to neutralize the excess charges. So in order to charge a conductor, we will have to use this process known as charging by induction. So prior to this video, you should have actually watched another video where this person demonstrated how he can charge with two spheres. So during that charging process, you can see that there is not much going on. You don't really see the charges moving. So I'm going to try to explain with this animation from my slides, and also with simulation. Yeah, we will start with the simulation first, because the simulation really show how the electrons really move inside the conductor. But of course the simulation is a bit different from the previous video. So same thing, we have two conductors. These two conductors is being placed on two beakers. Okay, these beakers are insulating stand. Okay, so unlike the video which are sphere, these two conductors are just rod. Okay, but similarly I have an insulator here which is being charged by friction. So you can see that when I bring the insulator closer and closer to the conductor, the electrons get repelled. Okay, so the electrons get repelled to the conductor on the right side. So the conductor on the right side has an excess electrons nearer to its right end, and from the left side the number of electrons is lesser than the number of positive charge. So basically the left rod over here, okay, I hope you can see my cursor, is actually more positively charged. Okay, so now with more electrons gathered on this side, all I have to do is separate. Okay, so I separate these two conductors. So you can see that with the two conductors separated, the conductor on the right has excess electrons, so it's now negatively charged. The one on the left, it has less electrons, so it's now positively charged. Okay, so I can move my hand away. You see, okay, so when I move these two conductor further apart, okay, the electrons simply rearrange themselves such that now we have a positively charged conductor and a negatively charged conductor. Okay, now if I bring this back, the electrons will just flow back and neutralize each other, so it becomes neutral again. Okay, and that's basically what happens. Okay, so again, bring this over. Okay, just push the electrons over to the other side. Okay, and when I separate, now I have two charged conductors. It's that simple. Yeah, that's how I can actually get two charged conductor just by doing this. Okay, just remove the hand, and then yeah. So with these two charged conductor, I can do other experiment. Okay, and let's go to my slides now. Now let me show you using my slides animation, how do we charge by induction for two conductors. Now this animation from my slides will be closer to what the video that you watch is showing. So we are going to look at how the electrons movement is like. And before I continue, just note that for when we are drawing the electrons and positive charges, we only draw the excess charges. Okay, so we don't do it like the simulation where we actually draw all the plus and minus. We only draw the excess ones. Okay, so that's to make our drawing easier. So now in the video, the two spheres are touching each other. That means that electrons can move to and fro between these two spheres. I have a rod that is being charged by friction, and this insulator is negatively charged. Let's assume it's negatively charged, is brought near these two spheres. So what will happen is that the electrons on this side will get repelled, and they will repel each other such that we will end up having electrons on the right side. Okay, excess electrons on the right side. So you see, I don't draw the other electrons or positive charges, protons, etc. because they are, if I have a plus and a minus, it's considered neutral, so there's no need to draw them. Okay, so basically what I have is the electrons being able to flow through the two spheres. More electrons will be gathered on the right side, so there's the right side of the right sphere is more negatively charged, and because the left side is the left side of the left sphere has lesser electrons, is more positively charged. So to get the charged conductor, to charge these two spheres up, all I have to do next is to separate, okay, with the rod held in place. The electrons cannot flow back. Okay, now they are separated. Okay, there's no way that these excess electrons can go back. Okay, so I can remove the rod, and with the removal of the rod, the electrons will redistribute themselves, and therefore we now have the left sphere being more positively charged because it has lost electrons, and the right sphere being more negatively charged because it has gained electrons. Okay, so the excess electrons will, the excess charges will be gathered around the surface of the sphere, of the object. Okay, so yeah, and that is charging by induction using two conductors. So let's continue with how we can charge by induction, and for this section we're going to just look at charging by induction using only one conductor. So in the previous part we see we can charge using two conductors, but what if one day you don't have two conductors with you, you only have one conductor? How do you charge it? Okay, so I'm not going to go to my slides. I'm actually going to show you a demonstration video first. So let's go to my video. Okay, so in this video, I actually have a charged sphere. A sphere. This is not charged yet, and there is this serial. Okay, color it a little darker so they can see on the video, and you can see when I played it. Yeah, nothing is happening right now, showing that they are electrically neutral. So I'm going to move the serial away, and now I will proceed to charge it. Okay. So same thing, I charge an insulator by friction first. I bring it to the sphere, I touch it, remove my hand, remove the rod, and now the sphere is charged. Okay, now it's quite similarly impossible because you don't see anything happening, but I'm going to show you that if I bring the serial near, something is going to happen. Okay, so you can see that the serial gets attracted to the sphere, which shows that it is charged. Yep, and that's for charging. That is the method to charge up a single sphere. Okay, let's go through what happened based on the electron movement. Okay, so yeah. So when a negatively charged rod is brought near the metal sphere, what happened is the electrons are repelled. Okay, the electrons are repelled from the charged rod, repelled away from the charged rod to the furthest end of the sphere. So the electrons on this side keep pushing all the rest of the electrons. So you end up having charge polarization again, and on the left side of the sphere there are more electrons on the left side. So the right side of the sphere, because it has lesser electrons, so therefore it's more positive. So the left side is more negative, the right side is more positive. This sphere is still neutral, okay? It has not been charged yet. Now, you saw me touching it, right? Okay, touching it is a process of earthing or grounding the sphere. And what happened is, in this scenario, the electrons flows to the ground through my hand. Okay, the ground don't literally mean like the ground we are stepping on, but let me just show you the animation first. Okay, so the electrons flow to the ground. So what is ground actually? So let's go to my Okay, a ground is simply an object that serves as an similarly infinite reservoir of electrons. So basically it's a place where there is a lot of electrons, or it's an electron sink. Okay, the ground is capable of transferring electrons to or receiving electrons from a charged object in order to neutralize the object. So what happened is, in this situation, okay, the electrons are being repelled to the furthest end of the sphere, and yeah, that's the furthest they can go, right? But now when I touch it, I'm actually giving them an access pathway, okay, a pathway where they can actually escape out of the sphere. So they will take this opportunity and flow away, okay, and uh, with that, now my sphere is more positively charged, okay. So why won't the electrons flow back? Because there is a presence of a negatively charged rod on the right side, so the electrons are pushing each other, okay. So now they can get off, they want to get off, okay. So now after that I remove my hand, right? So when the hand is removed, other there's no other way the electrons can go in and out anymore. And so once I remove the rod, the charges will redistribute themselves. Okay, since there are now lesser electrons, this whole sphere is now positively charged. Okay, so it's positively charged. The charges will just rearrange themselves, so the excess charges will be at the surface. When the sphere is brought near, right, what happens is the sphere is uncharged. Charge polarization occurs such that the right side of the sphere is induced with a negative charge. Okay, so basically now, because the sphere itself is positively charged, the right side of the serial is negatively charged because unlike charges attract, right? So, and the left side of the serial is induced with a positive charge, okay? So this is due to charge polarization, which we talked about previously. Now, since the forces of attraction is stronger than the forces of repulsion, given that the negative charge side is closer to the positive charge, therefore the serial attracts the sphere. And yeah, and that's how we can charge up a single conductor. Okay, and in my slides, okay, that I give as notes, this is actually how the animation works. Let's just look at it again. So touching it causes the electrons to flow to the ground, and therefore removing the rod allows it to be positively charged. Okay, so importantly, next thing, what happens if I use a positively charged rod instead? When I touch it, alright, okay, so the charge distribution will be the left side of this diagram is more negatively charged, the right side is more positively charged. And my question is, what will happen? Will the positive charge flow down to the ground, or will the electrons flow up to neutralize the positive charge? Okay, think about it. Okay, so remember, positive charge do not move, okay, inside the conductor, so only electrons move about. And in this case, the ground is said to be a reservoir of electrons, right? So since there are more positive charge on this side, and there are positive charge from charge rod, the electrons are now attracted from the ground towards the hand, towards the sphere. So when the electrons moves up to the sphere, it neutralizes the positive charge, and now this part is neutral. Okay, the charge did not die or disappear. It's just neutral, so I don't draw the excess charge. And now the sphere, because electrons have entered the sphere is now more negatively charged. Okay, makes sense? More electrons has entered the sphere. Okay, so with that, this sphere, if I remove the rod, it will be the electrons will redistribute themselves, and this whole sphere will be negatively charged. Okay, yeah, and do note that it doesn't matter where my hand is touching. Okay, my hand can be touching on the right side or on the left side. Okay, the same process will still occur. Okay, so in this case, the electrons will flow to neutralize the positive charge, and in the previous one, when I have this process, okay, so if my hand is touching here, or it doesn't matter, it's touching here, okay, the electrons will still flow away, okay, to the ground. Yeah, so hopefully that will explain how we can charge by induction using one conductor. In this section of the video, we'll be talking about how do we discharge a charged object. So just like we can charge an insulator and conductor, we can also discharge an insulator and conductor as well. So the process of discharging is to remove excess charges from the charged body. So when a charged body is discharged, we say that it is neutralized. So for insulator, there are two ways. One is by heating. So if let's say I have a positively charged rod brought near a flame, the intense heat from the flame ionizes the nearby air particles. Okay, so you can see, so the negative ions is going to get attracted to the surface of the glass rod and therefore neutralizing the excess charges on the surface, and therefore the glass rod is discharged, okay, and become neutralized. Another way to discharge is using our normal humid conditions, which is why Singapore is not very easy to build up static electricity. Okay, because let's say I have a negatively charged balloon over here, and it is the surrounding air. Okay, a humid environment means that there's a lot of water vapor in the air, and water molecules can serve as a form of electrical conductor as well. Although water is not exactly a very good electrical conductor, but it can still conduct some form of electricity. And these excess charges will get transferred to the water molecules when they are touching the surface of the balloon in this case, or the charged object. So that's how we can discharge an insulator. And for conductor, all conductors can be discharged by Irving. So what is Irving? It's actually to provide a path for excess electrons to flow away or to that electrically charged conductor. So the symbol for Irving, normally we'll see this, we call it the ground symbol. Okay, so you see three lines and then a wire attached to it. So this was demonstrated where in the previous section where you can use our hand to touch the sphere that is, and then the excess electrons can either flow to and from the body. Yeah, and that is how we can neutralize the excess charges. Of course, if you have a very an object that is supercharged, okay, so that means the voltage is very high. There's a lot of charge build up. You're not going to use your hand to touch it to just to earth it, right? Okay, you're going to get an electric shock. So what normally people do is they connect a wire, okay, to a metal rod, and this metal rod is like really stuck to the ground. Okay, so yeah, so earthing is actually will always neutralize the earthing object will always neutralize the excess charge, and this is one way we can earth a very uh, an object that is that can build up big charges. Okay, so if you are interested to learn more about what earthing and what is the meaning of earth ground and why is it really called ground, okay, you can look up in Google. I can provide the link if you want. So this pole over here is literally stuck to the ground, okay, which is why the literal term really literally use the term ground and earth, okay, because it's literally ground and earth you see here. Okay, but for your level, all you need to know is that earthing will always neutralize the excess charges. So charges can either flow to and from the charged object. Okay, yeah, from the ground to the charged object or the charged object to the ground. And yeah, that's how we would discharge insulators and conductors.